Hello children. Today last day we had started with pair of linear equation in two variables, and I left you with one problem, correct, with two problems actually, and one was little whatever we had discussed, one was little different from it, okay, not difficult but different from it, okay, where you had to plot two two lines equations in one graph, and I told you to see what is your observation. Okay, now the question was, you bought 2 toffees and 4 candies and gave ₹8, and B bought 1 toffee, 1 candy and gave ₹5. Plot the equation on the graph. Okay, now before starting we need to first identify the equation. So let toffee be x and candy be y. Okay, if toffee is x, candy is y, we can say that 2 toffee means 2x and 4 candies means 4y. And how much money did he give? 8. This is our first equation, correct? And what is the second equation? That is 1 toffee, which means x, 1 into x is x, 1 candy, which means again 1, y is equal to 5, correct? It is our second equation, correct? I am erasing off this part as we do not need it. We have extracted our equation. Last class we have learned how to plot what are equations, okay, what are linear equations, and this class we are going to see how to plot what are your observations. Okay, now let us consider equation 1. Okay, now if I tell you to find out points for equation 1, means like as we do for one value of x, what will be the value of y, if you want to do that. Okay, now see, this equation already contains coefficients which are multiples of 2. So let us reduce this. Okay, you can reduce this, you may not reduce this, but it will be easy for us. Okay, so let us reduce this. That means I'll divide this equation by 2, okay, as 2 is the common factor for all the coefficients. So it will become x plus 2y is equal to 4, correct? And let us take from here, let us find out what is the value of x. Value of x is 4 minus 2y, correct? And let us, you can take y also as subject to the formula. In that, if you take y as the subject to the formula, what will be y? Y will be 4 minus x by 2, correct? 4 minus x by 2, and from there we can say that it is it will be 2 minus x by 2, correct? So whatever value you take for x and substitute in the equation, and you will get the value of y. You can do it in this method also, or you can do it in this method where you can keep x as the subject to the formula and y's value you will be substituting. Anything will do. Okay, so suppose first value, let me take y's value be 0. What will be x value? X value will be 0 into y's value is 0, y's value is 0. So what will be x value? 0 into 2 is 0 and 4. So x will be 4. Now let us take y's value as 1. So if I take 1 as y's value, what will be x's value? 1 into 2 will be 2. 2 minus 4 is 2. Correct? And now let us take y's value as 3. Okay? Y's value is 3. 3 into 2 is 6. Okay. Minus 6 plus 4. It will be minus 2. Correct? Okay. So I have got the points for my first equation. Now for the second equation. Now let us find out for equation 2. Okay. Equation 2, what do I have? X plus y is equal to 5. So I can put x is equal to 5 minus y, or I can do y is equal to 5 minus x. Okay, anything I can do. Okay, those who are comfortable in taking x as a subject to the formula, you can do with x, you can do with y also. So x and y, again we'll draw columns and we'll find out. But remember, if you're taking x as the subject to the formula, you will always substitute y, you will assume y's value and substitute, and you will get x. Once you will do with this equation, once you will do with the equation, it will not happen. Any one you have to choose from the beginning itself. Okay, so I'm picking this one. So y's value, let us take 0. Okay, x's value will be 5. When I take y's value as 1, x's value becomes 4. When I take y's value as 2, x's value becomes 3. So I have got all the coordinates. Okay. Now let us try to solve, let us see graphically how do we do 2 points together, 2 equations together in one graph. Okay. So 1, 2, 3, 4, 5. Here also 1, 2, sorry, minus 1, minus 2, minus 3, minus 4, minus 5, and this side it will be minus 1, minus 2, minus 3, minus 4, minus 5. This side 1, 2, 3, 4 and 5. Okay, this is x, this is x dash, this is y dash, and this is y. Okay, this is our we have drawn this. Okay, and this is our point 0. Okay, these are the 2 axes we have plotted. Okay, now as I have told you, the division that you are doing while plotting the points, okay, that should be always equal. Okay, that means if you are taking 10 small squares for 1, then for 2 also you have to take, there should be 10 small squares in between 1 and 2. Okay, uniformity should be there. Okay, and similarly for y also. Okay, now so when y is 0, x is 4. Y is 0, x is 4. Okay, so first point is this. Second point, y is 1, x is 2. Okay, y is 1, x is 2. This is our second point. And third one is that y is 3 and x is minus 2. 3 and minus 2. So this is our third point, and we'll draw a straight line that is passing through all these 3 points. If it is not passing also, at least by side you have to move, you have to put a scale and you have to draw a straight line. Okay, and this is our first equation. We'll write the equation. The equation was x plus 2y equal to 4. Okay, second one, when y is 0, x is 5. Y 0, x 5, which means over here. Correct? When y is 1, okay, y is 1, x is 4. That means over here. 1 and 4. Okay, and third one, y is 2, x is 3. Y 2, x 3, which means over here. Correct? So we'll draw a straight line again. Okay, now you see this is for the equation, that is x plus y is equal to 5. Okay, now see, this is I have drawn on the board. It's not a graph paper. Okay, so maybe for that it is not coming in proper way. Okay, but one thing you see, this both the lines are tending to meet at a point. Okay, only at one point, because two lines are converging. Okay, they will meet at a point. Okay, so this is from this observation you can see there will be a point which will be common to both the lines. Okay, common to both the lines. So in that case it will have one common point for both the equations. Okay, one common coordinate, like here we have different coordinates. Correct? All the coordinates are different, but as this is tending to converge at a point, there will be at a certain point it will intersect with each other and there will be a common point. Correct? This is our observation. Okay, from there we will conclude there are three types of representation of equations, okay, lines, when we draw on the graph, and we'll be discussing about those things in details in this video. Okay, so let's see. Now when you plot two equations on a graph, okay, there can be three types of observations. Okay, you will see certain equations will be there where the lines will intersect at a point. Okay, this can be the first one. Okay, sometimes when you plot the graph, you will see the points that you have drawn, that will be for both the equation you will get only one line. Okay, that can be another observation. Okay, and means if we have, this is suppose equation 1, okay, and this is suppose equation 2. Correct? For equation 1 and equation 2, when you draw the lines, okay, whether it be in positive side or in negative side, they will sometimes it may happen that in any of the graphs you may find that both the equations are intersecting, the lines of the equations are intersecting at a point. That may happen. Or you may see both the equations, equation 1 and equation 2, will have only one common line. That means whatever points you are getting for equation 1, coordinates for equation 1, similar type of coordinates will also be for equation 2, and hence you will have only one line for both the equations. Okay. And third observation you can see is when you find two lines are there, okay, which are never having any common point. Okay, that means they are parallel. Okay, when you have this type of graphs, okay, when you have this type of graphs, we generally, from the graphs, we generally conclude that this is known as, first let me tell you, this is intersecting one, intersecting at a point. This is coinciding, and this is parallel. Correct? So when we have this type of observation, we generally categorize them as this type of graphs will have one unique solution. Okay, by solving the equations graphically, okay, or algebraically also, okay, you will have only one unique solution. Okay, and when the lines are coinciding, that means similar points for both the lines, and you have seen that only one line is extracted from both the equations, you will find that those two equations have, or those two variables have, infinitely many solution. Okay, infinitely many solution. And when the lines are parallel, okay, we will judge them under, we will say that these two have no coincident point, or no solution. Okay, no solution. We also tell them as an inconsistent pair. Okay, inconsistent pair of linear equation. Inconsistent pair of linear equation. Okay, understood. Now we'll see that we'll check with how these are. Okay, different equations we are going to see, and to check whether it is true or not. Now I have three equations, three pairs of equations I have written. One is x minus 2y equal to 0, and 3x plus 4y is equal to 20. Okay. Second is 2x plus 3y is equal to 9, 4x plus 6y is equal to 18, and the third one is x plus 2y is equal to 4, 2x plus 4y is equal to 12. Okay. Now let's solve the first one. Okay. For the first equation, when we try to solve, what are the points that we get? Okay, this one if I take as x is equal to 2y, correct? So when y's value is 0, x value is also 0. Y's value is 1, x's value will be 2. When y's value will be minus 1, x's value will be minus 1 into 2 will be minus 2, correct? Okay, and for the second one, xy, this will be x is equal to 20 minus 4y by 3. Okay, when y's value is 0, y's value is 0, x's value will be 20 by 3, which means x's value will be 6.66. Let us take 6.6. Okay, when y's value is suppose 1, okay, y's value is 1, so x's value will be 16 by 3, which means it will be like 5.3. okay, and suppose if I take minus 1 means what? Minus 1 means plus 24, so 8, correct? So I've got all the points. Now let us plot. One, two, three, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and here 1, 2, 3, this side also, minus 1, minus 2, minus 3, this side also, minus 1, minus 2, minus 3. Okay, my divisions are not proper because you will be plotting in graph paper, so it will be more clear to you. Okay, now suppose first equation 0, 0, which means this point, okay, where x is also 0, y is also 0. Next is y is 1 and x is 2, y1, x2, which means this point, correct? y1, x2. Okay, second is y is minus 1, x is minus 2, y minus 1 and x is minus 2, which means this point. Okay, so this is my graph for the first one, first equation, equation 1, correct? Second is y is 0, x is 6.6. So 6.6 here you will be having, if you are taking 10 divisions, that means after 6, at the point of 6th square, we will be drawing. Okay, so y0 6.6. Let us consider this one. Okay, next is y is 1, x is 5.3. 5.3 means here one division will be there, 5, 2 places this side, so 5.3. okay, this is 5.3 and y's value is 1, so maybe here. Okay, and next is y is minus 1, x is 8, y is minus 1, so when y is minus 1, x is 8, so somewhat here. Okay, so you find there is one common point, correct? For this equation we have one common point which is intersecting both the equations. Now let us plot for the next one. So one incident point is there from the observation I have written there. Okay, let's solve this one. So for equation 1, x and y, I think I have to erase this one. Okay, So for equation 1 we have 9, if I am 9 minus 3y by 2, correct? So let us take y is 0, x will be 9 by 2, which means 4.5. okay, when I take y as 1, x becomes 6 by 2, which means 3. And when I take y minus 1, x becomes plus 3, 9 plus 3, 12, 12 by 6, which means 12 by 2 is 6. Okay, so this is my first points. Okay, second one, here also it will be 18 minus 6y by 4. Again, y if I take 0, 18 by 4, which means 4.5, correct? Okay, when I take 1, 6 minus 18 is 12, 12 by 4 is 3. And when I take minus 1, 6 minus plus this one, I get 6, correct? See, oh my god, we have same points. Okay, that means when I plot on the number line, okay, so 1 2 3 4 5 6, 1 2 3 4 5 6, 1 2 3 2 3 4. I'm not writing the points. Okay, so y is 0, x is 4.5, 4 and somewhat in the middle. Okay, y is 0, so means first point will be here. Second one, y is 1 and x is 3, which means over here somewhat. And y is minus 1 and x is 6, which means somewhat here. Okay, and similarly same points I have for this this one also. So that means equation 1 and equation 2 are both having a same line. Okay, equation 1 is also falling, the points are falling on the same line. Equation 2 is also points are falling in the same line. So we can see lines are coincident, points also similarly, points are coincident, correct? And the third one is what? X, y. From here we can find out 4 minus 2y, and for this one 12 minus 4y by 2, correct? So first one, let us take my favorite, y is equal to 0. Okay, so x will be 4, y will be 1 when y is 1. For the first one, x will be 2, correct? When y is minus 1, you can take any values. Okay, I am taking 0, 1, minus 1. That doesn't mean always you have to take this. Okay, you can take any values. Okay, so when y is minus 1, okay, which will make plus 2. Okay, so 6. This is a first, for the first one. For the second one we are going to do now x, y. So when y is 0, x is 6. When y is 1, 12 minus 4. 12 minus 4 is what? So it will be 8. Sorry. It will be 8 by 2, which means 4. Okay. And the third one, when y is minus 1, which means it will become 12 plus 4, which means 16. 16 by 2 is 8. Correct? So again, let us plot. So it will be 1, 2, 3, 4, 5, 6, 7, 8. Okay, and this side minus 1, minus 2, minus 3, minus 4, minus 5. Okay, and so on. 1, 2, 3, 4. 1, 2, 3, 4. Somewhat here. Okay, and this is a midpoint. So this will be what? When first one, y is 0, x is 4. Y is 0, x is 4. Somewhat here. Okay. Y is 1, x is 2. Y is 1, x is 2. Somewhat here. Y is minus 1. Minus 1 means what? Down. And x is 6. Somewhat here. So our line will be this one. Equation 1. Okay. And for the second one, y is 0. Y is 0. X is 6. 6. Okay. Y is 1. X is 4. X is 4. Somewhat here. And y is minus 1. X is 8. Which means somewhat here. So you see, we have got equation 2. So here you see, we have a coincident point. Here the points are same for both the equations. So we have only one line. And here you see, there are two different lines and there is no chance of meeting at a point. So these two lines are parallel. Okay. From there we can say, conclude, no coincident point okay lines parallel. Okay. Now from here let us observe the coefficients. Okay. What is the coefficient of let us consider coefficients of first equation. Equation 1 will be always a1 and equation 2, this is for x. Okay. Equation 2 will consider always a2. And similarly for y, equation 1 coefficient will be b1 and equation 2 coefficient will be b2. And constant of equation 1 will be c1 and constant of equation 2 will be c2. Okay, let us consider this and we'll see what is the observation of the coefficient. We have seen the observation from the line, we have seen observation from the points. Now we'll see observation of the coefficients. Now from the first one we see a1 by a2 and b1 by b2 and c1 by c2. Okay, what is the first one? 1 by 3, correct? This is 1, this is 3. This one minus 2 by 4, and this one 0 by 20. Now you see there is no this one also, if we reduce in lowest term, we get half. Okay, so this ratio, and this ratio, they are not equal to each other. Correct? They are not equal. So when they are not equal, okay, which means there is exactly one solution of the equations. Okay, and number 2 observation is they are intersecting lines. Okay, when there is no common thing in between the ratios, that means there will be only one solution of the equations, and they will be intersecting lines. From the second one, let us see. It is A1 A2 B1 B2 C1 C2. What do we see? 2 by 4, 3 by 6 and 9 by 18. Now this is half, this is also half, and this is also half, which means all are same. Correct? When all are same, we have two observations, that is coincident lines and number 2 is infinitely many solutions. Okay, and from the third one, let us see. A1 A2 B1 B2 and C1 C2. From there, first is half, second is also 2 by 4, and third one is 4 by 12. So this is also half, this is 1 by 3. Here you see A1 by A2 is equal to B1 by B2, but it is not equal to C1 by C2. Correct? So in this case we can say they are parallel lines. Always when we see the coefficient, we will from there only we can check and tell by seeing the line itself now that they are parallel lines and there will be no solutions of the equations. Understood? So from the coefficient itself we can judge whether the equations will have a solution, or they will be intersecting, or they will be coincident, or have infinitely many solutions, or they will be no coincident point, they will be parallel line, and there will be no solution. That's all we have for today's video. So this is your assignment 8, where I have given only one set of questions, 3 questions actually, but the thing you have to do only one thing, that is you have to compare the ratios of coefficient of variables and constant and judge whether these lines, okay, equation formed by solving these lines will coincident at a point, or will be intersecting at a point, or will be coincident, or will be parallel. Okay, and also solve them graphically if they are consistent. Okay, now one hint I have given, that if the lines are parallel, the equations are inconsistent. rest all consistent. Okay, only if they are parallel line, those lines those cannot be solved. There will be no unique solution for them, and in that case it will be inconsistent. Okay, and for rest of all the equations it will be consistent. So we have pair of equations. First one is 9x plus 3y is equal to minus 12, and second equation is 18x plus 6y is equal to minus 24. Second question is 3 by 2x plus 5 by 3y is equal to 7, and second one is 9x minus 10y is equal to 14. This is your second pair of equations. Okay, and the third pair we have 2x minus 2y minus 2 is equal to 0, and second equation is 4x minus 4y minus 5 is equal to 0. So that's all we have for this lecture video. We'll be coming with the next one.